Hello, my name is Richard Cusco and I'm going to present the paper entitled Comparative Analysis of the Performance of Maximum Power Point Tracking Algorithms in Photovoltaic Systems. This research is part of the project MIRAESP, specific innovative microgrid solution for the isolated rural areas of Ecuador. At the same time, this work is part of the project from the Research Group of Propagation Electronic Control and Networking PROCONNECT of University of the Armed Forces ESPE. The topics to be discussed are Introduction, Photovoltaic Systems, MPPT Control Algorithms, Result and Discussion. The algorithms designed are Perturb and Observe Technique, Incremental Conductance Technique, Fuzzy Logic Control, Neural Network Control, and Slide Mode Control. The constant growth of electrical demand, the depletion of fossil fuels, and the impact of their use on the planet have led to solid research of alternative energy resources for electric power generation. That is why the production of renewable energy sources has increased in recent years. As a result, there were 128 gigawatts of photovoltaic energy installed worldwide by 2019, where China and the United States were the countries with the highest growth, accounting for more than 40% of the photovoltaic installed capacity this year. In contrast, Brazil and Mexico stood out with a production of 1.2 gigawatts and 2.8 gigawatts respectively in Latin America. Although costs of solar panels have decreased in the last year, external factors such as weather conditions and partial shading limit the energy production of photovoltaic systems. Solar panels use the physical principle known as the photovoltaic effect, which is based on the incidence of a luminous flux on their surface to produce an electromotive force. In recent years, new manufacturing technologies have been developed that maximize energy extraction from solar panels. There are three characteristic curves of the operation of the solar panels. In black color, the current voltage curve. In blue color, the power voltage curve, and in the pink color, the power current curve. The points of maximum power correspond to the place on the power voltage curve where the voltage and the current values are the maximum as a function of temperature and irradiance. A maximum power point tracking (MPPT) algorithm is necessary to implement to cope with variation in weather conditions, ensuring to use the solar energy to its maximum. A photovoltaic system (PV) is defined as the set of devices involved in generating electrical energy from the solar radiation. The first diagram shows the photovoltaic system used to simulate the MPPT controllers designed for this purpose. Solar panel is the element in charge of generating electricity from solar energy. The equivalent circuit of a solar panel is shown in the following diagram. The converter is a device in charge of adapting the voltage by reducing or increasing. The topology used is based on a DC-DC boost converter. MPPT control algorithms. Perturb and observe algorithms (PNO) is one of the most commonly used MPPT controllers on the market because of its simplicity. This method is based on continuous observation and perturbation until an operating point approaching the MPP is found. Its response presents a continuous oscillation due to its methodology of operation. The image shows the flowchart used for design of the algorithm. Incremental conductance. INC. This method measures the gradual change of the solar panel's voltage and current. It analyzes three different regions: Region 1 located to the left of the MPP, Region 2 located to the right of the MPP, and the last region refers to the exact point of the maximum power. This algorithm starts from the definition of conductance to determine the point of the maximum power. Its response oscillates as does the PEO algorithm. The image shows the flowchart used for the design of the algorithm. MPPT based on fuzzy logic control. Fuzzy systems use a type of nonlinear control that attempts to apply a user-expert knowledge by using control rules. The fuzzy logic control defines its inputs concerning the power voltage characteristic curve of the solar panels. These inputs are the error E and the variation error CE. Mathematically, the error is defined by a relationship between power voltage. The output variable corresponds to an accumulator of the boost compared to the cycle. Five membership functions were used for the input and output. This image corresponds to the error input. This other image corresponds to the variation error input. And finally, this image corresponds to the output variable. The design rules are presented in the following table. MPPT based on a neural network considers the temperature and irradiance as input variables and the MPP voltage is the output of the neural network. The training of the neurons is performed based on a range of random temperature and irradiance data. The structure of the neural network controller design has three main parts: selection of input and output variables. The inputs to the neural network are temperature and irradiance. Given these inputs, the simulation schemes varies from the previous ones. Network architecture. The neural network consists of two neurons in the input layer, 10 neurons in the hidden layer, and one neuron in the output layer. Network training. The training of the neural network is carried out from a set of 1000 data of temperature and irradiation. This image represents the new simulation scheme for the neural network MPPT controller. MPPT based on sliding mode control. Use the PNO algorithm to generate a reference voltage. The sliding mode control compares the output voltage parameter of the solar panel with the reference parameter calculated by the PNO algorithm, allowing to it calculate the tracking error. The calculate tracking error and its derivative are used to generate the sliding surface. Finally, through the control out, a duty cycle is produced that will force the converter to operate at the MPP. Sliding mode control uses measurements from a specific solar panel to generate the sliding surface. In this research project, a variant of the PNO algorithm is incorporated to generate this surface, thus not limiting the algorithm to a single panel. Two of the simulation scenarios are presented below. Case 1. Testing under constant temperature and variable irradiance. The data for this scenario are 25 degrees Celsius and a range of values for the irradiance. Case 2. Testing under real conditions. The location selected to use meteorological data belongs to the Amazon region of Ecuador. The data belong to January 2015 and are measured with a sampling period of 1 hour. The results show that output power oscillations are constant in almost all controllers, executing the sliding mode control and neural network control. The most commonly used conventional MPPT methods in the market, perturb and observe, and incremental conductance, are the ones that show more oscillations. The amount of energy extracted is comparable in the perturb and observe, incremental conductance, neural network, and sliding mode control algorithms, although all of them present an adequate tracking of the maximum power point. The physiologic control algorithm tends to extract lower power values at low irradiance levels. It is recommended to use the perturb and observe and incremental conductance control algorithms for low and medium scale installations. However, they are the methods with a more significant presence of oscillations. The neural network and sliding mode control algorithms are recommended for a large-scale installation, since their power extraction is higher. Although the COVID-19 pandemic has affected all industries, photovoltaic is one of the few to show positive growth worldwide. At the same time, it is projected to be one of the main sources of power generation in the future. New panel manufacturing technologies such as Half-Self, PERC, and bifacial have novel features that maximize solar energy extraction. However, all these technologies start from a common principle. Therefore, formulating a model based on mathematical data allows us to understand how each parameter interacts within the energy production. New methodologies have been applied to overcome the shortcomings of the conventional algorithms. Therefore, three different types of more sophisticated, robust, and better performing MPPT algorithms have been designed. Thank you. If you have any question, please do not hesitate to contact us for further information.